All right, welcome back to our last one, 3 out of 3 rotations. And this is usually one that's a little more complicated for everybody because we usually use a little bit of fractions to describe our rotations, or we use our degrees of a circle or angles to measure our rotations as well. And then, of course, we throw in the words clockwise and counterclockwise to make it all the more complicated. But today, we're going to review these ideas. We're going to try and solve them and help you apply them so you can do it perfectly on your own without any assistance. So the first things I want to review, again, we have our chart paper here, and we got our x-axis and our y-axis going like this. And I drew 3 figures here. And the first thing you need to notice is, again, we're going to be talking about a turn center. A turn center is a spot that doesn't move. Everything spins around the turn center. So here you can see the turn center is right on the object. And these are ones you're probably more familiar with. And when we rotate it or turn the object, it turns around that turn center. So here we have our object, and now I'm going to turn it a quarter counterclockwise. So counterclockwise is the opposite way, and I'm going to turn it a quarter, which is just another 90 degrees up. So the new object, here's the turn center, this one is going to rotate like this. So it's going to rotate around that pivot, that spot there, and it's only going to do one stop over, which is a quarter of the way. So I'm going to draw it right here. The shape of it and size of it does not change. I'm going to draw it in its new spot just like that. It's still connected to the turn center like this. Now imagine if I told you to turn it halfway, or 2 out of 4, or even turn it 180 degrees. Well, it's going to turn over to this side over here. Let me get a different color so you can see it. I'll do this one in blue. And you can see that if I did another counterclockwise quarter turn from my original, I'd end up here. And if I did one more counterclockwise turn, another quarter counterclockwise turn, I'll do it in green here so you can see it, or purple. I'll do it in purple so you can see it. I'd end up here. And now I'm 3 out of the ways around. So I started here, this was 1. And I did a quarter counterclockwise turn and ended up here, and that was 2. Then I turned again around that turn center, and this was 3 out of 4. 3 out of 4. Then when I went all the way around, I ended up doing 4 out of 4 turns. So I moved it all the way around the turn center, and that was a full 360 degrees, or 4 out of 4. Remember, that turn center is important. Let's look at this one a little more challenging. Here we have the same object again, but this time in this object here, the turn center is not on the object. In fact, it's not even on the vertices. It's a total of 2 squares away. That's really important because you have to respect that and keep it 2 squares away all the time. So if this time my object moved from here to here, if I move the object from here to here, what kind of turn did it do? What kind of how was it rotated? Remember, I respected the 2-line difference there, and I kept the same shape and the same size, and I rotated in this direction, and it was only a 90-degree turn or 90-degree rotation, and it was only one stop over. So what would it be? If you said this was a quarter turn clockwise, that would be correct. So remember, you need to always rotate around that turn center and keep that space. If I was going to go halfway around, remember you got to keep that space there again, and my square would end up in this area down here. And if you were going to do 3/4, your square would end up over here. How do I know that? Because I kept it 2 spots away like that. And then when it goes all the way around, that would be 4 out of 4, or 360-degree turn clockwise. Our last one, we have a triangle here, and when you do the triangle, you'll notice which way the triangle points changes as you rotate. Again, pay attention here. We have a one-stop gap, a one-line, one square between the turn center and the object. We're going to go counterclockwise on this one, and I want to go halfway, or 180 degrees, or 2 out of 4. Those all mean the same thing. 2 out of 4, 180, or halfway. They all mean the same thing. What would it look like if I did a counterclockwise turn? Sorry, that's not counter, that's clockwise. If I did a clockwise turn, 180 degrees, what would this triangle look like? Will it be pointing this way, or will it be pointing that way? Well, let's find out. Do a quarter turn, do one step. Remember, keep it right there. And our triangle is the same size, 3 squares long, 1, 2, 3, and it's the same size, like that. and like that. So this was just a quarter turn. We only did 90 degrees here clockwise, but notice how it's already shifted which way the arrow is pointing. And again, you need to respect that one square space because that's how the original was. Now I want to do one more. I want to go up to 180 and do a halfway turn. And this time, keep the space there. And I'm going to do an exact same size of triangle. So I have 3 on the bottom. And I'm just going to turn it so I can see it a little bit better. And now our triangle is pointing to the left. And that was 180, 2 out of 4, or what we actually call halfway. And that was a clockwise turn. So hopefully when you can remember when you're doing your rotations, remember that we measure our rotations using quarter fractions, half fractions, or we use degrees such as 360, 90 degrees, 180. Remember we use the word clockwise, counterclockwise. Remember you need to respect the space of the turn center. Hopefully that clarifies rotations, and I hope that helps. That ends today's geometry lesson.